Hello Professor, my name is Usha Sri Karuturi. Today I'll be presenting a technical architecture of data lake powered by Apache Hadoop. Modern organization generates large volume of data in many different formats, and data lake helps in storage all the information in one certain location or central location while keeping it the data in original and raw form. This is across the technology that enhances its kind of stable, effect, and flexible data environment. What is data lake? The data lake is centralized repository that stores unstructured, semi-structured, or structured data in any scale. Unlike traditional data warehouses that require data to be fully cleaned and formatted from storages, a data lake allows data to be kept in its native state and applies structures only when it needs of an analysis. This Schema-on-Read approach makes data lake more cost-effective and adaptive and better suits for big data and advanced analysis. When it comes to Hopper core architecture, this established a data lake using two main components. One is HDFS and YARN. HDFS or Harvard Distributed File System is responsible for the storage, and it is the master-slave structure. These are the name node managers, metadata, and the data nodes stores that actual data blocks. YARN, which stands for yet another resources negotiators, manages the process and computing sources. The response management takes as such as machine. Together, HDFS and YARN provides the foundation for storage and analysis huge data. HDFS storage data relies across the clusters of inexpensive servers. When the files are uploaded, it is divided into blocks and stored across the multiple data, such as each block is automatically replaced using 3 times. That enhances the higher ability in case nodes fails the distribution and fault tolerance. Design allow HDFS to scale the main machines and storage petabytes of data especially efficiently, make it details for the data lake environment. When it comes to YARN plays the role of clusters, managing the coordinators and distributing the process of workloads. When the application such as Spark is submitted, YARN first launches and the application master and then allows CPU and memory processes across the multiple nodes to execute data. This design allows several users and different frameworks to run workload at the same time without interfering with each other, supporting true multi-tenant analysis inside the data lake. And when it comes to ecosystem, the ecosystem includes the powerful. This is the powerful ecosystem that contains data architecture. Sqoop is used to be transfer data from related database into HDFS, while Flume collects large and streaming data. Hive provides the SQL-like interfaces for analysis, and it provided test pads in a memory processing for ETL, workflow, and machine learning. These tools allow organization to inspect, organize, transform, and analyze data all within the Harvard environment. This having the technique called end-to-end process technique. The complete data lake workflow starts with raw data integration using tools like Sqoop, Flume, and Agha, and stores the data in the form of HDFS. Metadata is recorded in a Hive meta store of easy discovering, analyzing through these to submit processing job and the Spark transformation. And YARN distribution, the workloads across the structures. One processed fine data is stored into HDFS, where it can be accessed to the business intellectual tools and the transformation and across the intelligent tools and application for the reporting insights and the decision making. When it comes to conclusion, acts Harvard servers are the cross the technology and make the data make the data lake particular and scalable. HDFS provides snooms to the fault and tolerant data storage. YARN enhances efficiency and distribution the data processing. And additional ecosystem tool supports integration, governance, and analytics. Together, they create a complete and effective solution for enterprising value, big data management. And thank you for listening.